Hi, everyone. Welcome to STEPCon, the Science and Technology Educational Partnership. I'm Barry Barish. I'm a professor of physics here at Riverside, and I have a great interest in technology and what you're learning. I think it's a fantastic opportunity for all of you, and I'll try to just give you a few reasons why. First, STEPCon itself is sponsored by by CERT, the high school virtual learning module. It's a high school virtual learning module, and it's sponsored by our hosts who are behind me. That unfortunately we're virtual, but this is the Bourne College of Engineering at UC Riverside, and also the Center for Environmental Research and Technology. The approach this week that you're going to get is really a hands-on introduction to the high technologies, some of the high technologies that are moving our society forward, that are where you'll be years from now. I mean, now in high school, you study mathematics, chemistry, biology, maybe physics, and you'll get to college and study engineering. All this is very academic. And this week, you get the opportunity to do something much more hands-on and much more introductory to where it all ends up when some of you, hopefully a lot of you, end up going into science or technology and engineering. So this week, we'll find that you'll interact and learn with learning modules and then hands-on experimental work. And the fields are a variety of ones that are really right there where we are moving the world and our society ahead from where we are now. The first one, hosted by Matt Barth, who's the director of CE CERT, is on smart cities and transportation. So smart cities and transportation is a buzzword, of course, but it's a very important concept that now is being used in the design and making cities work. For example, in transportation, which you'll learn about by making it intelligent enough to satisfy the needs much better of the population. Interestingly, I personally have some experience with smart cities in Italy. I do a lot of my research in Italy, and there's two different places in Italy that are doing very advanced work in applying smart cities. One is a city called L'Aquila, which was near the laboratory I work in, which was destroyed by an earthquake about 7 or 8 years ago. And in rebuilding the city, they have a lot of attention to rebuilding it in a way that's a smart city, in terms of the transportation, the communication in the city, the interaction and design between the commercial part and the residential parts, and so forth and so on, the kinds of things that you'll learn. The second place in Italy, just happens, my experiences in Italy, is in Milan, where they had, some of you might have possibly been there, they had a World's Fair for about 10 years that ended in 2015. And now they're taking the land, a large piece of land in fairly central Milan, and redeveloping it into a residential, commercial, and research place with a research hospital, for example. And it's being done as a smart city with a lot of attention to the internal transportation modes, things you'll learn about this week, and so forth. So I think, learning about smart cities is one of the most forward-looking things you could do, and those of you taking that will learn about that this week. The second one, which also is an area that I have a touch with, is artificial intelligence and machine learning. That'll be hosted by Barak Galler. She's an assistant professor of electrical engineering and computing here at UC Riverside. And machine learning and artificial intelligence are an area that had great promise for years, a lot of hype about what it was going to be used for, but now we're there. So The tools that were needed to develop machine learning and artificial intelligence have really come into their own in the last decade or more. Has many uses, everything from using them in old people's homes to transportation or, um, for example, autonomous vehicles, or even in sciences. I use artificial intelligence or machine learning to study what we call glitches, which is kind of what the device develops as background for doing the science we want in our gravitational wave detectors. So it's used from the most advanced science to kind of practical things for all of us. And you'll use Python, which is the tool that we all use to use machine learning on some nice examples. The third area I know a little less about is microgrids. And that's important and becoming more and more important because of the fact that locally, in any sort of local community, we're starting to use renewable energy much more than we did in the past. And renewable energy has this feature that it's intermittent. It gets a lot of it when the sun shines or the wind blows, and less at other times. And so you need some way to be able to handle the ups and downs. And a microgrid is a connection locally that uses these features to run everything locally. And then it has to connect to the bigger grid where when it has an excess, it puts power back into the big grid. And when there is less renewable power, it comes into the local grid. And so you'll learn and do projects simulating some microgrids, which is more and more going to be and is an important topic. Sudral Ula, who is an expert in this area, will guide this part of the project. Lastly, there's a clean air section. I think that's subscribed. It's got to do with using little devices and measuring air quality, something that we're all reminded of and have been in the last weeks with the forest fires in California, how important it is. And an expert in that area, and you'll again be hands-on, will be guiding that, and that's Nicole Cleary. So those are the areas. And all of you will have learning modules to learn about it, and you'll have projects that you work on. The projects will then be evaluated. The best ones will move forward to some final judging, and then on October 16th will be an award ceremony for the best work that we've done. That's all I have to say as an introduction. Take advantage of all this. It's a wonderful experience to have so young and give you some guidance, and absorb it, and most of all, have fun. Good luck. Bye-bye.
Hello, my name is Matt Barth. I'm a professor here at the University of California, Riverside. I'm a professor in electrical and computer engineering, and I've been here at UC Riverside for approximately 28 years. So I've seen UC Riverside really grow up over the last couple of decades. I also serve as the director for the Center for Environmental Research and Technology. That's part of the Barnes College of Engineering, and obviously a research center that's focused on environmental issues. I also am serving as the UC Riverside Faculty Director of Sustainability, which I'll tell you a little bit more about in just a moment. As you probably know, the University of California has a very strong commitment towards sustainability. All 10 UC campuses have this carbon neutrality initiative where every campus is trying to become carbon neutral by the year 2025. This is a very daunting task, and we're very busy on this at University of California, Riverside. We're developing new energy systems that includes a lot of solar panels, a lot of energy storage techniques, and we're trying to deploy that across our campus. We also do a lot of fun projects with the students. We have worked on a solar greenhouse, we work on renewable fuels, and a number of other very interesting projects. But let me tell you a little bit more about CSERT, or the Center for Environmental Research and Technology. We started out about 28 or 29 years ago, and it was really to focus on three main issues. Focus on air quality, transportation, and then also energy systems. We are a research center that's located off campus. We have approximately 4 buildings that we work in, both laboratories and offices. And we have a lot of space in order to conduct our research, which is a great thing to have. We involve our students quite a bit, both undergraduates and graduates, into our research. So they get to have a lot of fun too, working in the different laboratories. If you look at the different research topics, I already mentioned we do work in air quality, transportation, and energy. Our main focus started out in air quality and trying to get to the point where we can really clean up our air. About 30 years ago, the air quality in Southern California was really, really poor, where we had a lot of smog, a lot of particles, and things like that. So we've worked on that from a number of different angles in terms of our research. We've worked on cleaning up the vehicles, right? So both cars and trucks and buses, developing new technology so that the emissions that come out of the tailpipes has a lot less pollution. We've worked on also stationary source emissions, so there's quite a bit to do yet in improving the air quality. Air quality, of course, is related to transportation. So we have a lot of vehicles here in Southern California. And as a result, the mobile sources, both cars and trucks, contribute quite a large fraction to our air quality problem. So what we try to do in the sustainable transportation area is come up with new ways of making transportation more efficient. We're trying to electrify a lot of the different types of vehicles, and all these different things really help to improve the environmental impacts of transportation. There's a number of different energy projects we work on, including renewable fuels. We work on solar energy and solar energy systems, and then also what we call smart grids or microgrids. This is working with the electrical grid in tandem with our transportation systems. So working on those things together, we can really come up with better solutions here in Southern California. Then, of course, we also do a number of different projects that are related to climate change. As I mentioned earlier on, the University of California has a very strong carbon neutrality initiative, and this is directly related to trying to solve the climate change problems. If you look at the research that I personally do, I already mentioned that there's a lot of vehicles out on our highways and our roadways here in Southern California. And if anyone's driven on these roads, you know it's very frustrating sometimes with a lot of congestion and just a lot of problems on the roadways. So what we try to do with what we call intelligent transportation systems is to develop new ways that can really improve the traffic flow, that, as I mentioned, lower emissions, has a smaller amount of energy use, and then also improve safety. So the whole research area of intelligent transportation systems is very broad. Some of the specific things that I work on are electric vehicles and how we can bring electric vehicle technology and deploy it as quickly as we can, both in cars and trucks, as well as buses. We also work on what we call shared mobility. So rather than everyone going out and getting their own personal vehicles and driving everywhere, there's a lot of new ways of sharing vehicles, including ride hailing, which I think a lot of people are familiar with, as well as car sharing, bike sharing, and different things like that. That's all part of shared mobility. And then the fun stuff is with connected vehicles and automated vehicles. So connected vehicles are allowing vehicles to talk to each other, so vehicle to vehicle communications. And then they also have the ability for vehicles to talk to the infrastructure. So these are all important new developments that we're working on as part of our research. And the hope is to improve safety, mobility, and reduce the impact on the environment. The funner stuff is automated vehicles. I think everyone has heard about automated vehicles. They are coming. There are a number of different prototypes, a number of different fully automated vehicles on our roads, but we have a long ways to go before there's quite a number of these automated vehicles and a lot of things that we have to solve. This deals with control systems. It deals with how the vehicles communicate. It deals with policy issues too. So there's quite a bit of interesting research going on in the area of automated vehicles. And really, this is the main focus of our lesson plan that we're going to provide in this particular research area. So we're going to dive deeper on automated vehicles and let you know the ins and outs of how they work. So for now, I'll say goodbye, and then we'll see you on the next lesson. Thank you.
Hey guys, welcome to the Virtual Center for Environmental Research and Technology. My name is Nigel Williams. I'm a PhD in mechanical engineering and I do research here. So I'll tell you a little bit about myself. I got my PhD at UC Riverside. I also got my bachelor's degree there. Well, it's probably better if I start from the beginning. So I actually grew up in Riverside. I went to school here, I went to North High School, and that's where I discovered my love for math and physics, and also video games. So as a result, I chose engineering as my major in college. I started doing research here at the center and around the end of my freshman year. And my professor, Matt Barth, was very helpful in guiding me. Gave me lots of research to do. I learned lots of new skills and got a lot of stuff done. So working at the research center is pretty nice. It's a good group of people. They're all pretty honest. But I've been blessed to have a good group of people to work with. I often work in teams on projects. And as the research center's name might suggest, it's mostly stuff for eco-friendly stuff, environmentally friendly technology. And it's actually something I got into around high school. I was always interested in things like solar and wind power. It's like, if we can get energy basically for free, why not? And after all, things like coal and oil are running out, so we can't depend on those forever. So I continued doing research related to eco-friendly things up till now. And it's important because I don't know if you've heard, but we're supposed to lose about 99% of our coral reefs within about 10 years or so. So lots of things are supposed to happen. And basically it's up to us, the ones who are working right now or about to start working, like you guys, to do something about it.